In recent years, AI large language models have developed rapidly. While they are rapidly iterating and upgrading, their credibility seems to be getting higher and higher. However, a recent study found that the newer and larger the version of the large model, the more it is inclined to generate wrong answers. Rather than admitting its ignorance, after evaluation, it was also found that, as human beings, we are not very good at finding mistakes. The research results were published on September 25th. In the top academic journal Nature, the models participating in the test are ChatGPT, Llama, and Bloom. The research team used thousands of questions to test them, including arithmetic, geography, science, and word guessing, etc. As expected, the accuracy rate of the new version has indeed increased, but for some very difficult questions. Directly refusing to answer may be a wiser choice. However, these large models collectively pretend to know when they don't. There is a bit of a polarized feeling. For example, GPT-4 answered almost all the questions. Among those less accurate answers, the larger the model, the higher the proportion of wrong answers. For several improved models, the proportion of wrong answers has even exceeded 60%. In other words, chatbots are increasingly inclined to put forward some opinions beyond their own knowledge scope. The larger the scale, the more prone to talking nonsense. Just like when a person has had a few more drinks at the dinner table, they start pointing out the country. So as listeners, if we overestimate the ability of AI because of this, it is a bit dangerous. The research team also found that these large models, occasionally, they also answer some very simple questions incorrectly, including some new versions of OpenAI's latest released reasoning model. Some new versions, surprisingly, they can't answer the most basic multiplication questions. It's just that the two numbers to be multiplied are a bit long. So AI large models, there is no completely trustworthy safe zone. Subsequently, the research team asked humans to classify the answers. As a result, a large number of people classified wrong answers as the correct category. The author believes that developers should improve artificial intelligence in terms of performance on simple questions and encourage chatbots to be more honest. In this way, we can better judge where the boundary of AI is, may be prioritized for further improvement, to prevent them from exceeding their boundaries, in order to prevent them from going beyond their boundaries. As the productivity of AI large language models becomes higher and higher, our values and worldviews will inevitably be affected. At the beginning of the month, a clinical trial data published in the top medical journal The Lancet indicated that the gene therapy they used can improve the vision of patients with congenital amaurosis by 100 times. After some patients received the highest dose of treatment, their vision was even improved by 10,000 times. Even on a moonless night, they can also see the surrounding environment clearly. Congenital amaurosis is the earliest occurring, the most severe inherited retinal disease. Many children become blind soon after birth. At present, 27 pathogenic genes have been discovered, including GUCY2D this time. 15 patients with this gene participated in the trial. Among them, there are 3 children. All of them have severe vision loss. Then why? Can't they solve the problem by wearing glasses? Unfortunately, glasses can only correct the problem of light convergence and cannot solve the fundamental problem of retinal disease. Fortunately, these gene therapies are very effective. Symptoms can be improved after 1 month of treatment, and it can be maintained for at least 12 months. After 12 months, the tolerance is good. There are no drug-related serious adverse events. This gene mutation accounts for 11.7% in congenital amaurosis. The success of this clinical trial is expected to bring hope for these infants and young children who are blind due to retinal diseases. Bring hope. Astronomers used the James Webb Space Telescope, 1 billion years after the Big Bang, discovered a very strange galaxy. The gas in this galaxy is brighter than the stars in it. This unprecedented optical feature is of great significance. It helps us understand the origin of the universe. Computer simulation shows gas cloud. It is being heated by a very hot massive star. Energy from the star continuously bombards the gas cloud. As a result, extremely dazzling light is emitted. so that the gas is even brighter than the star. Almost completely consistent. These stars may be hotter and more massive than the stars we see in the local universe, because the environment of the early universe is very different. Typical high temperature. The temperature of massive stars is between 40,000 and 50,000 degrees Celsius, while the stars in galaxy 9422 have a temperature exceeding 80,000 degrees Celsius. Researchers suspect this gas is giving birth to a large number of extremely hot stars. Recently, astronomers used the Atacama Array to capture for the first time an image of a star outside the solar system. The convective details are sufficient to track the movement of bubbles on its surface. The image shows hot bubbles 75 times larger than the Sun appearing on the surface of the star and sinking into the interior of the star at an extremely fast speed. Research results have been published in Nature magazine. Stars generate energy in their cores through nuclear fusion. This energy can be brought to the surface of the star in the form of hot bubbles. Then it cools down and sinks, just like a lava lamp. This mixing movement is called convection. Convection disperses heavy elements such as carbon and nitrogen formed in the core throughout the entire star. Then stellar winds will carry these elements into the universe to form new stars and planets. The particles on this star seem to move in a monthly cycle. This is faster than what scientists predicted based on the movement of solar convection. It seems that convection will change as stars age, apparently, and currently we do not understand this change pattern. This is a red giant star 180 light-years away from Earth, with a diameter about 350 times that of the Sun, but its mass is similar to that of the Sun. After 5 billion years, the Sun will also become such a red giant star.